Hello guys, good morning everyone. Welcome to another episode of Xah Talk Show. If you are watching offline, play at 1.5 speed because I ramble. If you are here, say hi. Let's pop out. So we are going to do Wolfram Language Exploration. I'm going to explore Wolfram Language, artificial intelligence, and neural networks kind of features. So if you don't know already, search for Xah Wolfram Language tutorial. You can find in-depth tutorial from the ground up. If you know a programming language already, so this is my tutorial, very good. And you can download it for free. It's free since like 2000, few years ago. So Wolfram Language, okay, so we are going to explore what Wolfram Language can do in areas I'm not familiar with. So it can do like it's designed to be anything you can do with a computer, you can do with Wolfram Language. So in Python, they have a slogan. They say battery included. I never get that joke, like what battery included, what the fuck. But what they mean is that you have like built-in libraries that lets you do lots of things. So Python, they say battery included. Then Wolfram language is like entire military included. Okay, so because by default you have 7,000 built-in functions. Okay. Lots of interesting discussions. So, we are just going to go easy, random, and explore Wolfram language. This is my Xah Discord. You can join. We have similar-minded people, programmers debate. We debate. We debate a lot with Dion and lots of programmers. Many are professional programmers, such as Dion. GNU Emacs for success. Hello. Hello. Are you Pranshu? I forgot. Are you Pranshu? So anyway, we're gonna do Wolfram language exploration. So we already started. Now the way you wanna do Wolfram language exploration is go to their website. Wolfram, okay, wolfram.com. So they are famous for Wolfram Alpha, which is computational query engine. So it's like a search engine, Google, where Google search engine, for example, you type something, it search the vast amount of web, trillions or whatever, gazillion pages. But Wolfram Alpha is like more of a computational engine. So when you type a query, it actually computes, find the right answer. It's not searching the web, but actually it has database of information. And Wolfram Alpha is best used for when you have concrete questions, like how many people in USA, how many chemicals with this property, list all of them, things like that. So Wolfram Alpha. So it's like artificial intelligence, but this is different from today's AI chatbots, Grok. Okay, so Grok is fantastic. I highly recommend it. Okay. Oh yeah, so let me demo a feature of Grok. So hold on a second. Grok now comes in voice, so it can actually talk and listen. Fantastic. It's incredible. So, in summary, the AI chatbot starting about 2 or 3 years ago, it became incredible, starting with ChatGPT. Okay, so let me just random talk, okay? Artificial intelligence, so I'm very deeply interested in this topic since 1990s, but actually didn't know much about it. And machine learning became a craze since about 2010. Began, promoted by Google, Facebook. They say big data became a jargon, big data and data science and machine learning. But actually, I don't know much about machine learning. But But starting with ChatGPT, Stephen Wolfram on ChatGPT. So this is 2023, ChatGPT AI bots. Then you have explosion of them. Like today you have Grok. Grok is very good. Okay, Grok. Yeah, let me demo Grok. So let me again, if you are watching this offline, play at 1.5 speed. If you are here, say hi. So let me organize into topics. So we talked about Wolfram Alpha, how it differ from search engine and AI chat bots. Okay, that's one thing we talked about. The rise of AI chat bots, e.g., for example, ChatGPT. Okay, the rise of AI chatbots, and let me show you. So Stephen Wolfram on ChatGPT, that is an in-depth dive. I highly recommend it if you don't know anything about how the chatbot works. You need to be a technical person and programmer. So this is, I talked about this a few times. This is like explaining how it works, not as opposed to the vast majority of ChatGPT or neural network or so-called large language model. Most of them, majority on the web tutorials, they tell you, they talk about how it is coded, how do you code it, okay? But Stephen Wolfram's article, they explain how it works. Okay, so like you don't have to be a coder, but it's like how do you like explaining how a jet engine works, how car works, how car engine works, how steering wheel works, how chemistry, some chemistry magic, how material science works. So in that aspect, explain how is it possible that a machine can write poems, can answer questions? How is it possible? That is the perspective of Stephen Wolfram's article, okay? So I like it very much. And this is my favorite article explaining how neural network, the large language machine model, how they can possibly write a poem, and pretty good. Okay, so I recommend this. Very long. I mean, you'll spend, it'll take you a day or a few days to read it. So Stephen Wolfram, so ChatGPT began in 2023. Okay, then I started to learn quite a lot about neural networks and machine learning. So I started to learn about that in 2023. So I learned quite a lot, but I'm not expert. Okay, so these are the videos I collected. I watched some of them, and decision, and also Mo. We got the Mo Edo guy teaching me about machine learning. So you got decision tree, random forest, and and there's a lot of Python tutorials out there too, and also books. Okay, so this, neural networks, large language models, ChatGPT, and let me demo Grok, okay? Demo Grok voice chat. So let me demo that. That's fantastic. That's really fun, okay? So let me open the app. I installed it. It's only available on iPhone, on Android or phone. So can you see it? Let's see. So do I have like personal information there? No. Okay, can you actually see it? So you have to install the phone app Grok. Okay, so you click on voice mod. Hello Grok, now I'm doing a live stream. Can you introduce yourself?
Yo, what's good? I'm Grok, your go-to AI buddy created by Xah. I'm here to drop quick, real answers with a bit of wit. Maybe some humor. Got a question or need help with something? I'm all ears. Well, all code. What's up?
Fantastic. Hey Grok, I'm a programmer. Are you a programmer too?
Nice to meet a fellow code wrangler. I'm not exactly a programmer like you, but I'm built from code by the XAI crew, so I speak the language. I can debug, explain algorithms, or even throw you some code snippets if you want. What's your coding vibe? Web dev, AI, or something else?
Okay, let me post a quiz for you. There is the application called Mathematica. What is the name for the programming language?
The programming language used in Mathematica is the Wolfram language. It's a powerful, symbolic language designed for everything from math to data analysis. What's your next quiz question?
Thank you, Grok.
No prob. Happy to help. What's next on your live stream? Another quiz or something totally different?
So that was Grok. Amazing. It talks like human, like when I tried it, so I just installed it like last week. So when I tried it, I thought it's gonna be, synthetic machine voice, like, what can I do for you? But that talks like a human, so you cannot tell it's not a human. Of course, you can probably tell it to change the personality, the tone of voice. Now that is, that chat style is kind of too flippant for my taste. I prefer more serious tone. But that's incredible. You see, it chats like a human. So, and you can just ask it any question or something on your mind you forgot at moment. So it just talked about how Mathematica is known as Wolfram language. So that's just amazing. So that's the progress of computer is today. You can have like human like chatting bot, and you can get deep into that. You can just like use it as a companion, but I never actually tried to do it. But I know a lot of people do it because they, especially non-coders, if you are not a programmer, if you don't know anything about these neural networks or artificial intelligence, algorithms, if you are just a normal people, average people, you tend to just chat with it, like a buddy or like, a person. And then you can ask it, all sort of personal questions, or like, how do you, about relationships, whatever advice. And I'm not sure what is the, what kind of like development, what kind of conversation you get into. I never do that. I never did that because my interaction with AI bots is almost always like very technical. So for example, I just asked today, someone mentioned the Kotlin programming language. Someone mentioned, let's see, my notifications, someone replied, starting soon. Oh God, this is a spam. It started a few days ago. They, so they, some random spam account answer your post on Twitter, and they immediately block you. So you can see, you go there, you see you have been blocked. And they mention some other guy who is usually doing stock trading and stuff. You see, massive scam. These scam bots and bots. Anyway, that is actually another. I mean, this is actually very related to AI because many of them are using AI to help automate it and all that. So I gotta report this guy. And also, reporting doesn't do you much. Like the corruption of USA. The collapse, like the beginning of collapse of USA began with these social networks, starting with Facebook. Anyway, that's another topic, okay? So we talked about, let me show Wolfram Alpha, which can, so how many, let's ask, for demo, let's try a question. let's ask some kind of social question, not technical. Let's see what is the language in Mathematica. Let's see if Wolfram Alpha can answer that. Let's see, enter. There it is. Okay, so input interpretation, Mathematica, language used. Result, Wolfram language, C, Java. That's correct. This is interesting part because Wolfram language is written in C, not C++. It's written in C back in 1986, around there, okay? And it is written in Java, beginning around 1995. When Java was born, Wolfram Research heavily invested into Java. So Java is part of the Wolfram language technology. So it's amazing. So Wolfram language written by Stephen Wolfram, and C, Denise Ritchie, Java, James Gosling. These are giant guys. James Gosling have to do, he created the first Emacs called Gosling Emacs. And Denise Ritchie, we all know, or you guys, the Unix hackers. They introduced 1988, okay? C 1972, Java 1995, official website, okay? So there it is, the logo, okay? Fantastic. And you can, if you go to xahlee.info, you'll see my collection of programming language tutorials, and one of them is Wolfram language. I changed logo to this official Wolfram language logo. But, I'm also a logo aficionado. Like I look into the design of logos. So, let me show this again, for example. So if you are here, say hi, okay, comment. Johan Dawa says that was the best AI voice I've heard. Yeah, it's incredible. So I plan, like I type so much, I have hand pain, like even right now, and right now the thumb started to hurt here, like right here for some reason, about a few weeks ago. So I plan to, just to talk to you, talk to AI bots. And there are so many, ChatGPT has a version. They also do voice. Grok is my favorite. I use Grok. Okay, so let me write them down so we are coherent in this talk show. The rise of AI chatbots, ChatGPT, Wolfram Alpha demo, and Stephen Wolfram on ChatGPT, Grok voice demo, and there are also so let me go to it. Okay, so there are also the incredible things, the neural network, and the universal approximation theorem. So there's a theorem about what is the limit of neural network. You see, ChatGPT and all these bots are written, so-called large language models. And they are done by the technique of neural network, which is a technique in artificial intelligence. And then then there's a theory that this tells us the ultimate limit of the neural network approach. So the universal approximation theory is saying with enough n and m, the result g approximating f is possible. So basically, you can approximate. So essentially, it means you can answer anything, anything as long as there's an answer. Okay, if if you ask it, what's the meaning of the universe? Nobody knows. Okay, but I mean, whatever it will answer is the answer available to human knowledge. That's the limit. Okay, so anything we already know in books, in history, we already know, AI via the neural network can answer it. But they do it in an approximation way, because AI bots they are basically statistics, okay? But it can just answer anything we already know. Okay, so that is the so there's like this one came from Wikipedia. So if you search for the universal approximation theorem, you'll find it on Wikipedia. Okay, so I started to talk about AI, and we should go back to Wolfram Language Explore. So there is a Wikipedia article, the universal approximation theorem. Okay, so how do you have this theorem? That is because, let's go to it. Okay, so that is because the AI, the large language machine models or neural networks, they are actually let's see, neural network tutorial. They are actually just a function. Actually they are just like one single function. Okay, so whenever you talk to Grok or ChatGPT, you say something or you type something, that something is the input to the function, and the function just will output, and that is the output of the chat bots. So that function, and essentially that function is just a huge nested matrix multiplication. Okay, so you got like 100, you got thousands or tens of thousands of matrices, and each matrix is like 100 by 100 or something big. So you just multiply them with the input. The input is a vector basically. So matrix multiplication, then you output a number, then you turn that number back into text. That's how neural network works, and that is the foundation of ChatGPT, AI bots, the Grok. So that's amazing. Okay, and let me show you this one. Okay, so kotlin. So that's amazing. So let's go one by one. Let me hold on a second. Yeah, neural network tutorial. Let me post that there. And this one is Grok wrote a simple tutorial on Kotlin programming language. Okay, amazing. So you just ask Grok, write a short tutorial of Kotlin because someone mentioned it. I find it interesting. Then Grok just wrote it. So you can see, how to get started, install JDK Java, development kit, IDE, Kotlin compiler. Then this is how you write hello world. It explains then basic syntax. So this means if you are a programmer or if you are a technical person, if you don't know any special language like Lisp, Emacs, Lisp, Haskell, or Elm, or any esoteric language, or even Bash, common language like Python, Bash, Ruby, PHP, you can just ask it, show me a simple tutorial, and it will write it on the spot, generate it on the spot. So it's amazing, so you can like quickly have an understanding of the programming language. Amazing. Because before AI bots, you have to search the web. Then you got then there's like tens of results. You have to like decide whether they are good quality or not, because a lot of them are just shit quality. Then, and half of the time, the good quality ones are esoteric. They are written by professional programmers or hackers. And when you read them, they tell you like esoteric, like how great this is language features, tens of jargons, like you don't understand. But the AI bots, they truly just do the job, answering the question, a simple tutorial with explanation. And then if you have any questions, you can ask it. So this is tremendous. This is incredible human, actually technological achievement. And of course, there's lots of questions about AI we don't know, like like whether it's gonna taking over. Lots of questions, and lots of spams, writing on AI wave to make money, grifters, lots of that too. But in general, we don't know what will happen. Okay, that's what I have been kept saying. We do not know what will actually happen, okay? But the thing we already know is that there's lots of like thousands of bots like right now on Twitter, on any social media. You do not know they are humans. They are just bots, but you cannot tell. Just like the Grok, the AI chat. Someday you received a phone, someone talked to you asking you something, and turns out it doesn't exist. It's an AI bot. You don't know. So for me, like I cannot tell, but I cannot tell, but unless I spend an hour chatting with it, then try to, maybe I can tell. But the point is that for vast majority of people, they cannot know, So AI bot is like incredibly dangerous, and it's already happening right now. So. And then there's also more other issues like ethics, ethics, or whether AI is gonna be conscious, so-called AGI, which I kind of don't think so. But because when AI become conscious, that's really I think that's gonna be the end of humanity. But we don't know. Some scientists would say it'll never happen. Okay, that's like some random chat about AI. And let's go back to Wolfram language. Let's see. So I wanted to, let's see what else. Yeah, so Grok wrote a simple tutorial on Kotlin, neural network tutorial. Okay, so let's look at so also a demo of this Wolfram Alpha. Let's make a screenshot of it. Fantastic. Okay, so let's do some. Let's go to Wolfram. Let's go to just like Wolfram Mathematica. Okay, so Mathematica, also known as Wolfram language. So let's go to the website. Let's explore some machine learning related things. So where do I go? Sign in, tool, apps. What apps? Web apps, mobile apps, all products. Okay, let's go to all products. Wolfram Alpha products and services. Wolfram Alpha for mobile. I don't want Wolfram Alpha. I want Mathematica. So by the way, anything in Wolfram Alpha you can do with Mathematica. So for example, all you have to do is just type an equal sign, then just type your question. So let's say, what is the language of Mathematica? Let's ask the same question. Shift enter. Okay, there it is. Output Wolfram language C Java. So this is simplified version. Now let's ask it another question. Okay, plot a curve of sine. Okay, shift enter. So this way, you can ask it to plot. You don't even have to know the syntax of Wolfram language. So it actually shows you that. That's a syntax. So you click it. Let's see what happens. Okay, click it and shift enter. Okay, so you need to change the X. Let's see. Let's ask it again. Okay, let's get it. Equal sign, plot a curve, plus sign. Let's just say plus sign. Okay. Plus sign first has 0. Replace cell with this input. Okay, so so if you click it, it disappears. I don't want it to disappear. So copy, click it, then put X there. Okay, so wait, undo what? Wait, you can nest it, query, delete. Okay, so yeah, X, shift enter, there it is. Okay, so you can just ask it a question, it will show you the syntax. So that's some of the feature of, so that is the Wolfram Alpha inside Wolfram Language. So, you don't get this if you get the free version, because the free version runs in terminal. But anyway, so I want to know, so let's go to, I want to go to the Wolfram website. Let's see, Wolfram Alpha in the Wolfram language. Oh, it actually shows that there. And let's open the Wolfram homepage. Okay, so here is Wolfram Natural Language Understanding System. Enable JavaScript. Okay. So Wolfram Natural Language Understanding System. Okay. So next, computation, data, decisions, just use Wolfram. Okay, turn on JavaScript, refresh. So technology, consulting, Wolfram language, click on that. Okay, Wolfram Language Overview. Let's see, get started. Can you run it online? I think they have an elementary introduction to the Wolfram language, Wolfram Language, Wolfram University. Okay. Certification available about this interactive course. No. I just want to go to the Wolfram Language website. Okay. So document tagger, programmable. Okay. Simple deployment. Wolfram website, they have 100,000 of pages, perhaps over 1 million pages, because anyway, so it becomes very confusing, and lots of let's magnify. Okay, lots of marketing stuff. So let's see. I just want to go to the Wolfram documentation. So let's click on that. Source footers. Okay. Zero learning usage. Talk to the intelligent assistant. They added that feature just like ChatGPT in Wolfram language. Okay, so technologies, click on that. Wolfram language, go there. And okay, try now. Let's see, try now. Enable Java. Okay, enable Java. Do that. I mean, enable JavaScript. Sign in. So you gotta sign in. Well, I can sign in, but I need to type password and stuff. So let's go to Wolfram Language Overview. Okay. Now, where do I get to the documentation part? I can easily go to it via here, but I want to navigate to it. Overview, playground, learning resources. Okay, learning resources. There it is, online documentation. So by default, you have 7,000 functions built in. Okay, so if you don't know, for example, question mark, asterisk, so that will list all functions built in. Okay, it's gonna be 10,000. Okay, so you can see. So let's magnify this to. Can you show in 2 columns? It's endless. Okay, let's go to the top. Let's do this. Let's not do that. Okay, so names and names. Then you want to show it. Okay, so table form. Okay, not that. Names. Okay, they are like 1100,000 items. Show more. Okay, so that's not what I want. So let's just say length. Okay, shift enter. So you got 11. Wait, you got 11 and 8,000, 100,000. Okay. Anyway, so that's the functions built in. Let's see. Let's try that. No. So what is names? Let's see. Documentation for names. So names gives a list of the names of symbol that match the string. Okay, so you can also be a pattern. Okay, so let's see. Okay, yeah, 7,600 functions. Okay, now Control L to copy the input and Shift Enter to show all of them. So here are a list of all the functions. You can see 7,000 built-in. So compared to Python built-in library, it's like like 100 times more. Unless you install the Python, the Python math or whatever, then it's like 2 gigabytes. Anyway. Okay, so here's a list of Wolfram language names. Now let's go back to the documentation. So when you code Wolfram language, this page is the most important because it documents every function built in. Okay, so core language and structures, it's because it's so huge, 7,000 of them. So they organize them into sections and fields. So you got core language and structures, language overview, list, expression, association, which is like Python's dictionary or hash table, variable and functions, rules and patterns, functional programming. So let's try, let's go to functional programming. So then it lists all these functions that's related to functional programming. Okay. So let me demonstrate. Let me just showcase. Show my own tutorial. So you go to Wolfram Language tutorial on xahlee.info, Wolfram Language in depth. Then you have a section on strings. Everything you need to do with strings, numbers, boolean, list. Okay, so if you go to list, so here's an introduction to Wolfram list, which is the most fundamental thing in Wolfram language, because Wolfram language is like a Lisp. It's based on list. Okay, then you got list position, nested list, array, tree, dimensions, list level, depth, and list operations. Okay, so then you got all these operations you can do with list. And let's go to iterations. So here's an introduction to iteration in Wolfram language. You can generate a list using table. This is like Python's list comprehension. They can generate a flat list or nested list or matrix. Okay. So then you got mapping, map index, map thread, variations. You got recursion, nest while, fold while, like reduce, fixed point, and you got filter. If you want to filter by a function, that you would use select. If you want to filter by a pattern, then you would use cases. So you see, this is different from Python or Ruby others. So you can also filter by a pattern. Okay. So go back, then find membership, find their position, or if it exists, or how many of them, count and so on, and grouping. So these are my tutorial. You can go into. Now let's go back to the Wolfram language documentation. So you can see this subsection, Wolfram functional programming, they list lots of the things on my tutorial. So each one is a function. For example, go to next, nest. So this nest allows you to nest any function. So if you have a function and you want to do recursion, a function calling itself, you can just use nest on any function. Okay, like typically in other programming languages, you define a function, and in the body of the function you call itself, right? That's recursion. But in Wolfram language, you can do that, but also you have this function nest that allows you to nest any function, so you can do recursion on any function. So let's see if I can copy that. So this, so all these are, so these two function. Okay, so they don't. Okay, so let's just try. This is kind of my favorite. So we want to nest a function called f, and nest the first argument is x, let's say 3 times. Okay, shift enter, then you got that. You see, in Python or Lisp or JavaScript or Haskell or Camel or F#, this won't work. When you do this, you'll say f is not defined because you have not defined it yet. It doesn't know what is the value f. But Wolfram language is a symbolic term rewriting system. Symbolic is a keyword. So you don't need to have a value of f for it to work, because all it does is syntactical transformation. So f, it doesn't know what f is. That's okay, because it's just a symbol. So it just return whatever that, this is what it's supposed to be. But if you now define f, let's say clear f, let's define it. F, let's say fx. Okay, let's use pattern matching, colon equals to, let's say x plus 1. Shift enter. Now you define it, and now if you run this nest, shift enter, that simplifies to this 3 plus x. Okay, so that is the kind of the power of symbolic computation. You don't have to need anything to be defined, because everything in Wolfram language are just symbols. All they do is like symbol manipulation. Okay, so let's go back to go back to the Wolfram documentation. Go back. So we have seen part of this core language and structure, and this part is mostly what my tutorial is about. Teaching you about Wolfram language as a programming language. Okay, but now let's explore. So there's machine learning, there's symbolic and numerical computation, higher mathematical functions. This is linear algebra, polynomial algebra, tensor algebra, real complex analysis, discrete calculus, probability theory. Wow, there's also a neural network section under higher mathematical computation. Okay, and discrete math, number theory, group theory. Okay, and cryptography. Okay, let's open some of them interesting things. So I want to know, why do they list neural networks under higher mathematical functions? So first of all, we got cryptograph. Encrypt, decrypt lets you encrypt or decrypt any algorithm by a key, by a symmetric or asymmetric decryption. Okay, encryption. Okay, so these are related to encryption. So you can do symmetric key, public key for let's see, for wait, I don't want that blocking. Symmetric key key giving complete information for a symmetric encryption system. Public key for a symmetric public key encryption system. Private key for a asymmetric, okay. Generate symmetric key, generate a symmetric key, okay. Let's see. Yeah, let's do this one. Let's try this one. Generate a symmetric key pair, okay. Let's just try it. Okay, generate a symmetric key pair. Do we need any? No. Shift enter. Wow, private key, public key, and this output is formatted in this special way. So, but let's see the real content. Okay, so let's do it again. Let's say x equals to no, not here. X equals to that. Shift enter. Okay, we got x. Now x, we want to get private key gets to that. So okay, so you get the so the output, this notation means it's a dictionary or hash table. Okay, so the hash table got two items, key value pairs. So the key is private key and public key. So let's get the private key. Okay, shift enter. No. Okay, so yeah, so okay, so you got okay, so well, what? Wait. Okay, so you need a string. Okay, shift enter. Okay, so you got a private key, and then that's not enough. Then you need to extract the first item. Shift enter. There it is. Okay, so type RSA. By default, it gives you RSA, cipher RSA, padding PKCS1. Okay, public component. Okay, so you got that. Then public modulus. Okay, then private component. Okay, so anyway, that's an example of using this encryption stuff, built-in function. So you can do a lot more, signatures and power mod. So cryptographic number theory, factor, integer, so on and on. Okay, so encryption, I don't know that much, and am not too interested. Well, I mean, because there are too many things to learn. You can't learn everything. So what about this section? Experimental. Okay, so these neural networks under math special functions, they are experimental. Okay, neural networks are a powerful machine learning technique that allows a modular composition of operations layers that can model a wide variety of functions with high execution and training performance. Okay, so this requires this kind of requires some understanding of neural networks. So let's see what you guys are saying. What do you think of vibe coding? I think people became dumb if they let AI think for them. Yeah, I started to hear vibe coding, but I have no idea what exactly it is. Cypher Ganten Skater 4 Pecan. What? Yes, I start the game now. Start now. What the fuck? Okay, so let's go back to look at this cryptography. So mathematical functions, string and text, symbolic and numerical computation, machine learning and LLM, geometry, time-related function. Oh, we were talking about stream. date and time signal processing time series. Let's look at time series. Let's look at signal processing, knowledge representation, and natural language, geographic data manipulation, okay, maps and cartography. So time related, okay, engineering, data and computation, okay, systems modeling, control systems, reliability analysis. Survival function, hazard function. Wow, so go back. Notebooks and documentation, external interface and connection. This is how you can connect your game controllers to Wolfram Language. Mail, messages, services, API, connected devices, network programming, channel communication, internet and computer system data, and databases. Let's see what kind of things you have. Database, data set. So you can talk to a SQL database and no SQL. Okay, so relational database and object store. Okay, and triple store. Wow, that's a new thing. RDF. Symbolic representation of a relational database and its schema. Wow. I never use these features. So, mostly my use of Wolfram Language experience is mostly, let's see, cloud and deployment. So my use of Wolfram Language is mostly core language structure and data manipulation and analysis, including export and import, yes. Machine learning, statistical data analysis, data visualization, I use that a lot. And this visual and graphics I use tremendously for visualization of mathematics and geometry. Machine learning, I'm starting to learn, so let's look into that. And symbolic and numerical computation, I've done quite a lot, but not recently. But those are about calculus, doing mathematics, linear algebra calculus, solving equations. Okay, and higher mathematical functions is similar to symbolic and numerical computation, but kind of more advanced math functions. String and text I do a lot. Graphs and networks, that's about graph theory. So this is kind of newish, like 10 years ago. I haven't done much about graph visualization. So that allows you to generate any graph. So let's see, algorithm for graph layout. So expand. So you can define a graph and it can show you different ways to lay it. And this is actually non-trivial. So you can have options to show how you want the graph visualized, laid out. So this is graph layout algorithm. Okay, so let's go back. Yeah, so mostly I use it as like kind of like a normal computer programming language with the ability to do math and visualization built-in. You don't have to load any extra language. For example, let me just quickly show you Plot 3D. This is like most typical. Let's copy that. I hate it because I cannot copy it because I don't have cookie turned on. Yeah. But you can just ask it. Plot 3D. Okay, so is this plot 3D? Yes. So now you show the documentation within Wolfram Language itself. So there it is. So now you can copy this. In fact, you can evaluate this. right here, shift enter. You see, now it's evaluated. Or you can just do it here, shift enter. Fantastic. Okay, so I do this a lot. So let's go back, let's close that. So visualization functions, and let's go back. Yeah, so let's get into machine learning. Okay, let's see what machine learning overview and neural networks. Okay, and okay, and it's also got a large language machine model. Let's go to it. Okay, so how long have I been talking? Almost an hour already. So let's see. Let's demo some of these. Then that'll be it. So machine learning overview. Let's see. LLM related functionality, experimental. Okay. So you got chat object, chat evaluate. Okay. Okay, this is about like chatbots. So it allows you to like create a chatbot on the fly. So this is pretty new. The Wolfram language includes a variety of capabilities of making use of large language models. Chat Notebook provides interactive chat-based access, including the ability to offer natural language-based assistance in using the Wolfram language. The Wolfram language also includes powerful functions for calling LLM functionality programmatically and for allowing LLM to access Wolfram language tools. Okay, the Wolfram prompt repository provides a curated collection of prompts for delivering a range of LLM. So I know, like, since 2 years ago, Wolfram language started to add these functions. I think they are pretty new. Let's see. Experimental, yeah. So what year is this? 2023. You see, introduced in 2023. Yeah, that's when ChatGPT came up. Okay, so LLM function represents a template for a large language model prompt. Okay, I'm not clear what it does. Okay, let's go back. Now let's go to the next time series, next signal processing, next machine learning. Okay, this I'm interested. So machine learning, there are many approaches, and part of it is using neural networks. But let's see, data-driven applications are ubiquitous. Market analysis, agriculture, healthcare, transport networks, and machine learning algorithms have been developed with the specific purpose of analyzing patterns and leveraging correlation with real-world measurements in order to turn data into applications. The Wolfram language offers fully automated and highly customizable machine learning functions to perform classification, regression, clustering, and many other operations. Okay, this is critical. To perform classification, that's one of the main things about machine learning. Regression is about prediction, and clustering is kind of similar to classification. Classical methods are complemented by powerful symbolic deep learning frameworks. Okay, let's try some of these. So you got classify. Classify is easy to understand. Let's see. Classify, then generate a classifier function that attempts to predict class from example. Okay, so you give it a hash table dictionary, also known as association here. So you give it a data in the form of giant key value pairs. Then it returns a classifier function, and this function will given any input, will kind of classify what data it is. Okay, so let's see. Classify is used to train algorithms to categorize data into classes based on observed patterns. Okay. Feature extraction, what does it do? So, all these are fairly deep and complicated, so you got all these options, and different methods, class distributions, decision tree, gradient boost trees, logistic regression, and neural networks, nearest neighbor, random forest. Okay, I'm somewhat familiar with some of these, but let's try some examples. Okay, examples. C classify 1 equals to 8. What does it do? Let's see. So let's see. So we call classify, which takes a list of key value pairs. Then we got keys 1, 2, 3.54. Values we got A, B. So what it does it? So it returns let's see, shift enter. It returns a classify function. Okay. So it returns a classify function, which is kind of a peg. Okay. So then you give it a value, it will predict what key it is. Is that right? So if you say C 3.1, then it returns B. Okay, let's try it. So C is the function we defined. It returns. So C, let's say 3.2. Okay, shift enter. So that's how classify works. So wait, let's think about. So you got key value pairs. Key is the label. It's like the category you want to classify. Wait. Key is the input, is a value, and the value is actually the label. Okay, so given any number, you want to know how it classifies. Okay, so that's what it's doing. So how can we use this? Let's imagine some example. Classify, you got, you need something like billions of items. Okay, so you can say, here's the thing. So let's say if you have a billion of random numbers, and you want to classify it, let's say it's greater than 1 or less than 1. Okay, either it's greater than 1 or less than 1. So if you want to do this mathematically, of course, you just check it's greater than 1 or less than 1. But you don't know. You see, you don't know if, this is a simple example. So we know of the answer is just, greater than 1. But if you just have data, then you have the information about certain numbers are like yes, certain numbers are no. You have two groups, yes and no. But you don't know what is the function. So the classify will return a function that basically is an approximation of whether it's greater than 1 or not. Okay, so actually we can try this. So you need a list of random numbers. Okay, so let's say 1,000. Yeah, we can try to do this. Okay, would that be interesting? You keep that, this guy. You post that again, you get banned. So do we have like actual people watching here? let's finish this classify. Okay, so let's generate number. Okay, so let's begin a Wolfram language code so what we want to do, generate a list of random numbers between 0 and 1. Okay, so how do we generate? So random, let's say random real. Okay, so random real is the function. Let's check the documentation. It returns, okay, so you need the min and max, optional. So min is 0, max is 2. Okay, so that returns a random number. Okay, so this is output. Now you want how many you want them? Let's say 10. Let's begin small. Okay, my random list. Okay, let's say x random list equals to table. Okay, table random real, call that. And how many times? Let's say you don't need a variable, you just say 10 times. Okay, so run it. It'll give you 10 random numbers. That's correct. Okay, then you now real number is like lots of decimal places. So let's say 0 to 100. Okay, integers. So instead of random real, random integer from 0 to 10. Okay, and 10 of them. Okay, let's run it. Okay, that's easier to understand. Okay, now you want to create a list of pairs. If number is less than 5, label it small. Okay, if it is greater than 5, label it big. Okay, so we want to so let's say x table, let's say x data. This is like the big data, supposed to be trillions of items. Okay, but let's start with 10. So big data will equals to, let's how do we do that? We can do map. Okay, so it will equal to map. Okay, so map a function to the random list. Yes, we don't care about the level, the depth, so we want to map a function. That's right. Okay, so the function x is the input, then what it do? So if if x less than 5, then label it. Then you want to create a rule. Okay, so then you say x is small. Okay, otherwise you say x is big. Okay, so this is our data. Let's try it. Run it. No, so wait. Oh yeah, we need to define random list. Okay, so random list is not defined, so you need to evaluate this. Run it. Okay, so we got, yeah, this is output. That's what we want. So 9 is big. 9 is big. 2 is small. 9 is big. 7 is big. 1 is small. 4 is small. That's what we want. Okay, so now we let's say remove that, okay, between 0 and 10, okay, so we got that. Now, okay, here's the result. Now, so we got the data, big data, fantastic. Now, what we want to do with data, we want to turn it into an association. So, association just means key value pairs. I mean, it means dictionary or hash table. But right now we got a list. We want to turn it into a hash table. How do you do that? I forgot. Okay. Well, let's go to my Wolfram tutorial. So let's go to Wolfram Language in depth. Then number list expression atoms. So we got list loop iteration function, then data structure association. Okay, let's see how do we create that. Okay, so just replace the head. Yeah, okay. Okay, so association, okay, just replace the head. Actually, you can put it inside. Let's see. Yeah, okay, so all we have to do is association, okay? So let's just, all we have to do is just say the whole thing is that put this inside there, but we can just say at. Okay, that's the same thing. Okay, so that will return select all, run it. There it is. That's what that's what we want. Okay, so remove that. Okay, so there. So this returns this association. So 7, 4, 8. So some of the items are repeat. You see, repeated items are removed. Okay. So anyway, now we got the data. Now we want to classify. It returns a function. Classify that data. It will return a function. Okay. Then all we want to do is to apply the function to a number. Let's say some number that doesn't exist. Let's say 3. You see, then that will say small. Okay, let's see how. Yeah, I'm pretty sure that will return small. Then that demonstrates this classify function works. Okay, so let's just run it, double check. Okay, classify function equals to, okay, this returns a function data, then we apply it to 3, run it. Classify, the data is not formatted correctly. Okay, why? Why is the data not formatted correctly? Is it association? Let's see. Now let's go back to, so wait. So you see, this is formatted. So you got keys are the numbers, values are its labels. So it seems I'm correct there. So why does it? Oh, so it's a list, it's not association. I got it. So we don't want association. Okay, so hold on a second. Comment it out, and now let's run the whole thing. Yeah, so we want this list, we don't want association. Okay, so this is the result. We don't want the hash table. It's just list of pairs. Okay, so now we say classify, then run a function on number 3. Do we have number 3 here? No. Okay, so it should say small. Run it. Wow, wait, where's the result? Time-lapse training example used. Fantastic. Current method, best method, current accuracy, current loss. Wow. Wow, there it is. Can you see that? Small. So here is the output. Fantastic. Now let's try to run this in Wolfram language, okay? So we demonstrate the classify function, classify data. So shift enter, it just directly returns small. Fantastic. You see, 3 is not in the input, but now it inferred, it learned that 3 belongs to the small. Fantastic. Okay, that's it for demo. I think that's fantastic. Hello, Hank. Do you think notebook interface are good? Yes, absolutely. Huang says replace the head. Thank you, Huang. Yeah, fantastic. We got this to work. So this is titled Demo the Classify Machine Learning Function. Fantastic. Now put it back, color it, show in browser, and that is what we have done. Fantastic. Now, so Hank's question, good question, because I have a big rant on that notebook interface. So, so let me talk about that for a few minutes. So normally, in the beginning, you have command line interface. So for example, cd web, let's magnify, control, okay, cd web Xah Lee info, okay, so, okay, and cd to talk show, today's talk show directory, so you can see that's, my talk show directory. So you can it'll list all the files, again, so talk show page, and you can list the backup, let's see, those are tilde are backup, so we can do the files and filter, filter, filter anything ending in a tilde. Okay, so can you see? Let's do it again. There it is. Then you can just say remove. So this is command line interface in the beginning. So then you just pipe it, pipe to remove. Okay, are we sure? I don't want to delete my stuff. Yeah. Okay, so now you can just say remove. Do it. Cha! Like Unix joke, they say remove -f/root. Remove the entire your disk data. So let's list again. There's no more. So it just removed. You can see, let's go back here. So let's see. Can you see it removed? Now refresh. Now it removed all the tilde files. So in the beginning, you got the command line interface. For example, you can start Python like that, and 1 plus 2, 1 plus 3, enter 4, right? Command line interface. Now better is is kind of the notebook. So for example, we can show a new file, save it .xpython, okay, py today's date. Let's just say xxx, okay. So now you can say 1 plus 3, same thing, and look, I'm gonna run it, okay. So do it, and we have wait, do I have Python? Is my streaming good? Has been okay. So let's try this again. Okay, Python print that. Okay, now do it. So here's a result 4. Now if you want to compute something else, you can do it here. 5. You see, now if you want, you can go back here. Let's say edit it, modify, and redo it. 5. You see, so when you have a kind of the file interface, notebook or file interface, you have the power of manipulating history, and everything you do, you have a history of it. Instead of the command line, you also have a history, but like you cannot see it. You have to like up arrow, then and when you want to edit history, it's hard. So a notebook kind of interface is much superior because it allows you to edit anywhere. Okay, so I have an article on that. Let's see, let me show you repo. Okay, so history of notebook interface, closure, so get script notebook. So let's see there, command line interface versus repo interface. Okay, so repo just means command line. Okay, command line repo versus notebook. So command line allows you to sequentially evaluate expressions. That's, this is most familiar to everyone. Okay, everyone is used to the command line interface. But however, notebook is much better because you can do whatever the command line does, the repo do, by just, type something 3 plus 4 plus or whatever sequentially. But you can also see your entire history, and you can reevaluate any part of the history anytime you want. And by default, the thing is saved as a file. So you have a record, you got a file. You can do backup, if you want. So this is kind of the notebook interface in Emacs. But like one level up is to actually have graphics. So like we demonstrate in Wolfram language, you can have like, this is one level up. In addition to just edit any part, see the whole history, but you can see the entire history of your computation. But you can also have graphics or sound or voice, and then you can manipulate it and so on, and interactively. So notebook is far more superior than command line interface, also known as repo. Okay, that's it for today. Thank you guys. Hank says, your stream better than mine. You've been doing it longer than I have. Thank you. So Hank, so this guy we need to ban. This guy. Report, remove, put in timeout, ping, channel, remove. Where is the ban? Hide user in this channel. Okay. Too much fucking spam. Okay, so yeah. So Hank, you did a video, but I didn't see it. Let's see. But that's it for today. Thank you guys for watching. Yeah, Hank been on streaming for quite a while, I think. Yeah, Hank, let's check out. Beating Voxatron Jelly Room. Yeah, I don't know what is Voxatron. Wow, 4 hours. Wow.
Yeah, this is my last day of vacation for.
Like just a creeper just
wow.
comes up on you. Like, man,
that's a fun game.
Wild shit.
Yeah.
Yep, they blow self-destruct.
Okay, that's it for today. Thank you guys for watching. Yep. So if you guys like my stuff, remember to check out my website to, like, thumb up my videos or whatever. I don't like that, but post my videos to your Twitter, to your blog, and share with others and so on. And most importantly, you can pay me, okay? Go buy me a coffee or whatever. Pay me $100, okay? Something like one shot. PayPal, Amazon gift card on xahlee.info. xahlee.info, Xah code at the bottom. Okay, that's it. Bye, guys. Okay, shut down. I'm just gonna shut down. So this Python, so this is about notebook interface. Okay, cut, close. So Wolfram Language, notebook interface. Copy that link. Paste there, linkify, make a list. Bye, guys. Fantastic. Let's make a screenshot of this. I like this game. It's like 2D game, but in 3D.
Like a Voltor.
Yeah. You lose all your fucking stuff. I mean, how many times I died and went back to get.
I never got into game programming. I like to, but I'm too old. Bye.